Okay, another challenging physics problem here. Here we have this 3-crate system. It's going to accelerate to the right because there's going to be an applied force. There's no friction in the system, and what we're going to do is we're going to accelerate it so fast that the M2 and the M3 are going to remain up. So I'll be looking at that and saying if there's no friction between M2 and M1 or M3 and M1, how can M2 and M3 stay supported? But remember that M2 has to get accelerated. So if the acceleration of the whole system is enough that the acceleration of M2 can hold up M3, then this whole system can move without M3 sliding down. So one more time the question, assuming no friction in the system below, determine the force F required to keep the top block from falling off. So let's start with that M3. If this system is going to be stationary, that M3 has to have balanced forces. There's some force of gravity acting on it, negative 9.8 M3. And so the tension in that string has to be balancing that force of gravity. So if that's true, that'll keep M3 from falling. If the pulley transfers that force all the way over to M2, so M2 is going to be subject to a force 9.8 M3. Now, as long as this whole thing is moving along with it, as long as it has the same acceleration, M2 is perfectly welcome to move. So that's going to be a net force. There's no friction. There is a force of gravity and a normal force, and they're equal and opposite, so we can ignore them. So that 9.8 M3 is going to accelerate the M2. So my net force, which is equal to MA, in this case, 9.8 M3 is going to be the net force, M2, and there's going to be an acceleration. So that top block is going to get accelerated at 9.8 M3 divided by M2. It has to accelerate at least that fast so that when it gets pulled to cause the acceleration, that pull can hold up the M3. Now, if M2 is going to stay put and M3 is going to stay put, what that means is that M1 has to accelerate right along with M2 and M3. So what force do we have to apply to M1 to cause that acceleration? Well, here, because that force is external, we can now treat the system as if it's one big object with a total mass of M1 plus M2 plus M3. What that means then is that this force that's applied to it, again, there's gravity and the normal force, but they're equal and opposite and cancel each other out. There's no friction. So this force applied to it is the net force. Now again, by Newton's second law, F net equals ma. This time, m is my total of all those masses. And the acceleration that I need to keep the big block underneath the little block is 9.8 m3 over m2. So, if I can apply a force of m1 plus m2 plus m3 times 9.8 m3 over m2, then what I can do is I can accelerate that bottom block so fast that it stays underneath the top block, which is accelerating to hold up the front block. So there it is. It is possible, even without friction, if those are perfectly slippery, to move the objects fast enough to keep the system from falling down.